Welcome back. In example number 2, we were able to find from velocity, acceleration, and position. And today, in example number 3, we're going to start with acceleration. And we're going to wind up with the position equation. And this is pretty much how physicists memorize all those formulas from your physics course. They know they work backwards from the antiderivative to get position. So let's kind of start with this. And this is kind of, like I said, this is kind of how Newton came up with his laws of motion. So given the acceleration of a particle is at negative 32 feet per second squared, we're firing a bullet from a .45 caliber gun. Its initial velocity is v0 equals 985 feet per second, and h0 is at 15 feet. So of course this is what? The initial height. We want to find the equation of position in terms of t. Now given we're starting at acceleration, we can't go directly to position. We have to go through velocity. And I know what you're all thinking. Mr. Wernell, I learned this equation in physics. Can we use that one? No, we can't. Okay, we're going to pretend like we don't know those. We're going to think like an early physicist. We're going to derive them ourselves. So given acceleration is negative 32, we're going to find velocity. Well, from up top here, we remember to go from acceleration to velocity, we have to use antiderivatives. So I am going to integrate my velocity, my acceleration function. I will integrate a of t. Don't forget the dt. Okay? Now think about this. What is this telling me? This is acceleration times time. That is what this is telling us. If this is negative 32 feet per second squared, I'm multiplying that by some time unit. What am I going to be left with? I'm left with feet per second. So I'm going to get a velocity unit here. So it tells me we're on the right track. Remember, I think somebody in chemistry once said, let your units work for you. I know what you're thinking. Finally a use for chemistry, right? So that's what this is kind of telling us. We're multiplying. So this dt is actually very important for us. If you don't have it, it's just acceleration. By multiplying acceleration times time, you get your velocity. So we're going to go ahead and integrate this now. We will get v of t equals the antiderivative of negative 32 dt. And I can do that pretty easily. This becomes negative 32 t plus c1. And we have to find c1. So did they give me a condition for velocity? Remember this is my velocity. I know v of 0 is 985. So I can plug that in. 985 equals 0 plus c1. So c1 is 985. So my velocity equation is negative 32 t plus 985. Now some of y'all might be thinking, I've seen that before, Mr. Wernell. It looks familiar. You should. C1, remember this is my velocity equation from physics. Remember velocity is gt plus v naught, or negative gt plus v naught. In other words, c1 is the initial velocity. And we have one of our physics equations. That's how we came up with velocity of a free fall. Now this is a free falling object, of course. Now we got velocity to get position, or h of t, I guess. They use h, so I should use h. If you use s, they're not going to be barely mad at it. So given velocity, go to position, I have to use my antiderivatives, and I'm going to go ahead and do that. I'm going to integrate my velocity function. So let's again look at the units. Write this down. Velocity is measured in meters per second, or feet per second. dt, that's your time. Well, what is velocity times time but your change in position? That's for later, though. That's your change in position. Velocity would be something, in this case, feet per second. Time would be in seconds. Those cancel. We're left with feet. So we like the units here. Let's go ahead and integrate the negative 32t plus 985. Again, don't forget the dt. You have to remember that. You will not get any credit if you don't have that. So integrating, this becomes negative 32t squared over 2 plus 985t plus c2. Now I'm going to simplify this just a little bit. Negative 16t squared, that should look familiar, plus 985t plus c2. And we can go ahead and find c2 by the initial height. H of 0 equals 15. And I can just plug that in. 15 equals 0 plus c2. Therefore c2 is 15. And I know what you're all thinking. Mr. Wernow, that looks kind of familiar to me. If this data time is 0, that's my initial height. Exactly. C2 here is our initial height. It's h naught. Now, this is why we prefer the C1 and C2 for the subscripts. Different constants get different subscripts because they mean something different for us in each case. So my final equation, h of t, would be negative 16t squared plus 985t plus 15. And I know what you're thinking, Mr. Wernow, that equation looks familiar to me. It should. Height from a free-falling object is negative gt squared over 2 plus v naught t plus h naught. Half of gravity, negative 32t squared. And this is how physicists came up with those equations in physics. All right. We'll talk more about that later on. You guys, hope you enjoyed the videos. I'll see y'all later. Bye-bye.